Hello, we're going to do a lesson on the coordinate plane. Just the basics here. You should know most of this. Let's just make sure you haven't forgotten any of it. Alright, so in this lesson we're going to have goals and objectives that include like ordered pairs, graphing lines, and horizontal and vertical lines. And this is one of the few things in math that we talk about that I can point you to sort of the source, Rene Descartes. And he was a philosopher and made contributions to math, science, theology as well. Two of his major works include the Discourse on the Method and the Geometry. The Discourse on the Method included just what sort of things can you be sure about? What sort of things do you have to doubt? How can you be sure that you really know something? And so this was a heavy influence on modern philosophy and science, and included the phrase, "I think, therefore I am," which gets some play in pop culture. The reason why that was significant was sort of one of the big questions in Descartes' day in terms of philosophy was, how do you know you're really real? And Descartes' answer to that was, I think, I have my own independent thoughts, therefore I am, therefore I exist. The Discourse on the Method was really the lead up to three specific works as sort of more like an appendix. They were in like the back of the book, so to speak. One was on optics, one was on, I believe, meteorology, and one was this work on geometry that laid the groundwork for what you and I call the coordinate plane, which was kind of a big deal because before this point you had algebra, you had geometry, and there were absolutely no connections between them, which is hard for you to think about because all the math you've ever done has used his ideas. I mean, they're built into it from day one now. The story of Descartes is a somewhat interesting one. He came from a well-to-do family. His dad was a merchant or a mayor of a town or something like that. They weren't nobles, they weren't super rich, but they had a pretty good life. And Descartes was a sickly child, so his family allowed him to spend a lot of time in bed, and he didn't really have to do a lot of work. And so basically he grew up kind of in this almost lazy, pampered lifestyle. And one day while he was laying in bed as a man, he was watching a fly crawl around the wall, and he had the really good idea that the fly was like a point, the wall was like a plane. You could describe the position of the fly on the wall at any given time using a number off the bottom of the wall and a number off the side of the wall, and that became what you and I know as the coordinate plane. Descartes was also to some degree, like, he enjoyed the fact that as he got older that he was becoming sort of well known within the right circles there in Europe. And a queen of Sweden basically sent him a letter asking him to move to Sweden. I'll take care of you, and you can be my royal tutor. And Descartes agreed to do that, partially out of probably the glory of being the queen's tutor. And he hadn't lived there for very long. He caught pneumonia and died. So, it's kind of almost anticlimactic, but that was his life in a nutshell. So, why is the coordinate plane important? Well, it connects algebra, which is things like numbers, operations, variables, and geometry, like shapes, position, motion. We're going to begin with a quick tour. And, this matches up to the notes page. So a lot of this you already know, but, bear with me. Make sure you know it. So the coordinate plane is created by intersecting two number lines at right angles. The x-axis is a horizontal number line. That mark, by the way, does mention that that is the right angle. That's how we normally wouldn't do that, but I did that just because of the first bullet. The y-axis is a vertical number line. The x-axis increases from left to right. The negatives are over here. The positives are over here. That's 0. For the y-axis, these are positive numbers. These are negative numbers. That's 0 right there. In fact, that point where the number lines intersect is called the origin, and it's 0 on both. The coordinates plane is cut up by the axes into 4 parts, 4 regions, and that's why it's called quadrants. Quad in this case means 4. And it is standard practice to label them with Roman numerals beginning in the upper right hand corner where it would be positive, positive, and go counterclockwise. And so I see people occasionally, it's always expected that you know these quadrants by name. So I've seen people miss questions before because they forget which quadrant is which. So if you're one of those people, try to get over that. Remember, you start up here with 1, and you go counterclockwise, and you almost always see it labeled with Roman numerals. An ordered pair represents a point or an exact location in the coordinate plane. When I say ordered pair, I'm sure most of you visualize this symbolic notation here, with the x and the y in the parentheses. The first part is the x coordinate. It comes off of the x-axis, the horizontal number line. The second part is the y coordinate. It comes off the vertical number line. So it's an ordered pair for a reason. It's a pair of numbers, and the order matters. The first comes off the horizontal number line, the x-axis. The second comes off the vertical number line, the y-axis. You probably have seen something like this at some point in your life. The part of this that I'd like to stress is I see a lot of people that forget that on the x-axis, the y-coordinate would have to be 0. And then the y-axis, the x-coordinate would have to be 0. And so sometimes people forget that for some reason. I'm not sure why that's hard for people. I think it's, somewhat counterintuitive that on the x-axis, y is 0. On the y-axis, x is 0. Alright. The next chunk of your notes page is all about linear equations and 2 variables. And we're going to just always, when we're talking about it, we'll just assume that the variables are x and y, but they don't have to be. So you've got a, b, and c are real numbers. They're usually going to be integers for us. A and b cannot both be 0. Then this is the part that's, the actual standard form here. ax plus by equals c is a 2-variable linear equation in standard form. The ordered pair AB is the solution point if this equation is true when x is equal to a and y is equal to b. And then we kind of have an example to kind of help with this. So here's our 2-variable linear equation, and we're going to check real quick to see which of these points are solution points. And so we just remember, this is x. Ooh, that was a little rough. That wasn't much better. You know what? Stop being lazy, or stop trying to be slick here. We've got to remember that this is x, that's y. Alphabetical order, x, y. So here we go. -2 times 0 plus 1. We're checking to see if we get 1. Well, that'd be 0 plus 1. If it's short enough, equals 1. So this point is a solution point of this equation. Let's try 3, 5. And the idea of these problems is, for whatever equation I give you, whatever points I give you, with a little work, you could figure this out, even if the numbers were fairly exotic. Oh, when you add those together, you will not get 1, you'll get negative 1. So that one is not a solution. Again, we substitute and evaluate. And we're going to get negative 1 instead of 1 again. So far we have 3 points. We've checked. Only the first one is a solution so far. Let's check the fourth point. So we substitute x and y in this case happen to be the same. That would be positive 2 minus 1, which sure enough does equal 1. So of the 4 points that were offered, 0, 1, and negative 1, negative 1 were solution points. So hopefully that makes a little more sense now. So we've got standard form, and then a solution point. You put in the x coordinate for x, the y coordinate for y, and it works. Not too tough. So we just did that. So what's a graph then? Well, graph is the visual representation of all the ordered pairs that are solution points. And so a lot of you are used to this idea of the point-by-point plotting, where you create an input-output table, you pick some x's, you find the y's, you plot the points, they line up, so you draw a line through them. If we won't be doing it in this lesson, but realize that for lines, because they're fairly simple, 3 points is the bare minimum. But for curves, which can be a lot more complicated, it's not uncommon to need at least 5 to 7 points or more before you start to get a good idea of what that curve might look like. So now we have another example. Oh wait, we can talk about that first. So like the basic idea of what we're going to do in a second is we want to graph this equation. So here's the x's that we chose to pick, 1, 2, 3, 4. We're going to be real boring. We put each of those x's in. 2 times 1 is 2, plus 6 makes 8. So on and so forth. Plotted the points. Oh, they happen to line up, so we drew the line. So we're going to do that for these 2 lines, and as an extra sort of bonus problem, we're going to also talk about where those lines would intersect. It's kind of a preview of things to come in the future. But in either case, we're going to start by making tables. And really I'm allowed to pick whatever x's I like, but sort of the general guideline is pick a negative, 0, and a positive. And be aware that if there's a fraction, like right here, you might want to pick x's that are easy to work with that fraction with. So I'm going to select for this one, just kind of real straightforward, negative 1, 0, 1. And for this one over there, I'm going to select negative 2, 0, 2, just because the 2's will be a little easier to take a half of. Once you've selected the x's, I don't care what order you go in to get your y's. Some people start at the bottom, like with the positives, work your way up. Some people start up here and work your way down. Some people do their tables with the positives at the top. It really doesn't matter to me. Let's start with 1. 2 times 1 is 2, plus 6 makes 8. 2 times 0 is 0, plus 6 makes 6. 2 times negative 1 is negative 2, plus 6 makes 4. So this line, which is blue, will go through 1, 8. Let's see, I didn't really plot that well enough, did I? 1, 8, 5, 6, 7, 8. Again, I guess we're just going to be real rough here. Your picture will look better than mine because the notes page has graph paper on it. So there's 1, 8, 0, 6, negative 1, 4, and then We'll look over here and cheat. Do I have a way to easily make the lines? 2 maybe. Ta-da! Not perfect, but it'll work. And I just thought I should switch this to purple. Now, I graphed that, and when I did it by hand, it looks quite a bit different. So I might have to pull up something here in a second to give you a better idea of what this should look like. Alright, so each time when I do -3/2 of this number, I pick 2 so that things will cancel. So -3/2 of 2, the 2's cancel, it's just -3. -3 minus 5 is -8. When -3/2 multiplied by 0 is still just 0, so -5. The negatives cancel, the 2's cancel, that leaves 3. 3 minus 5 is -2. So -2, -2, 0, -5, 2, -8, something about like that. Let's try to make the line. Alright, now, based on this picture, it looks like they intersect at like -4.5, 1 or something like that. Oops. And then the issue is that when I did this on paper before I got started, I had graph grids, so my picture's a lot better. But we'll say that in this case, if somebody only did this work, their estimate for the intersection would be like -4.5, 1 perhaps. When I did it on paper, if you look right there, to me it was like -3, 0. And then what I can do, let me pause the video while I do this actually. Alright, so I opened up a online graphing calculator. You can see the address right here. It's pretty good stuff. So we're going to graph y equals 2x plus 6 and y equals -3/2 x minus 5. And we can see that in this really exact problem, it looks like the intersection is about -3.1, -0.3. And so, depending on how accurate your graph was, you'll have an estimate. So my on paper by hand estimate was much better than my really rough estimate here, but it was still kind of, if you draw a circle around that point, like a fairly decent sized circle, the real is somewhere in the circle. We know that. We were supposed to estimate, so I'm going to call that good. You can write on your paper whatever you get as your estimate when you do your graph by hand. Because it's an estimate, there's not one right answer as long as your method looks correct. Okay, so we're actually almost done. Horizontal lines always have the form y equals number. So for example, the x-axis is a horizontal line. Horizontal, remember, is like the crossbar of a capital H. That's horizontal. Y equals 0. So any points on a horizontal line would have the same y coordinate. I think I threw an extra example in here. So what is the equation of this horizontal line? Well, it looks like y is always going to be equal to 3. And then you could name a bunch of other points like 0, 3, 4, 3, 5, 3, negative 1, 3. The big idea is that y is always equal to 3. Whereas with the vertical line, verticals up and down, the vertical line has the form x equals a, where a is a real number. The y-axis is x equals 0. On a vertical line, the x-coordinate is always a, the y-coordinate can change. If you have trouble with remembering horizontal and vertical, there are a couple mnemonics. Horizontals like horizon, like where the sun sets. So if you're at like the beach, maybe look a flat horizontal line. In sports, vertical often refers to when you're standing still, how high can you jump? So that might help you remember those. So in this picture, what is the equation of the vertical line? Well, what's always the same is that x is negative 1, so x equals negative 1. Other points would include like negative 1, 2, negative 1, negative 3, negative 1, 0, so on and so forth. And so last example, sketch the graph of a rectangle that has the given lines as sides labeled the vertices. And so here's our 4 horizontal and vertical lines. We're going to graph these. It's going to make a rectangle. And we're going to label the corners of the rectangle, the vertices of the rectangle. I'm going to graph the these are vertical because they say x equals. So I'll graph them in blue. I'm going to graph the horizontal ones in purple. Might be better to label that right. Don't want to run out of space. No, they're horizontal because they say y equals. Alright. So x is equal to 2. Well, x-axis, there's 2. I want a nice vertical line. Tend that straight up. And straight down. Your picture will be better than mine because you're not using the computer. X equals negative 5. Well, there's negative 5 on the x-axis. I need a nice vertical line. They're straight up. They're straight down. So this is x equals 2. This is x equals negative 5. So we're going to do purple. Y equals 3. And it's a horizontal line. Pretend that's horizontal. Y equals 3. And y equals negative 4. So here's negative 4 on the y-axis. Y equals negative 4. And then we'll go around in red and label the corners. So there are the 4 corners. That corner, if you look, you won't be terribly shocked, is 2, 3. X equals 2 and y equals 3 intersect at the ordered pair 2, 3. Here's x, here's y. Likewise, we're going to have 2, negative 4, negative 5, 3, and this would be negative 5, negative 4. And that'll do it. Hopefully that'll give you a pretty good overview of the coordinate plane. Hopefully it reminded you of a bunch of things that you might have forgotten about the coordinate plane. That's all we've got for now. We'll do some other stuff with the coordinate plane in the next lesson. Thank you for your time. I'll see you in class. See you soon. Thanks. Bye.